works with everything. All right. Good morning, everyone. So I'm also not a clinician, informaticist, bio anything. I come from a math background, and I learned signal processing by working on deployed systems for remote sensing. But a few years ago, I saw the light, and that light was actually this incoming train called Randall Wetzel in the VPQ and CHLA, so here we are. And the seeds for this talk actually came about last year when, during one of the PDC scientific committee meetings, I said, okay, here's a homework for you all, I said. Think about having proper holdout test sets. And so thank you, Nelson, for allowing me to expand on that homework, not really an exercise, but I think it's going to be a lot of thoughtful, careful consideration. So I want to start, and I think Nelson showed this earlier, with the vision statement for the PDC. I'm not going to read all of it, but some keywords: promote discovery, application of knowledge, improve treatment of critically ill children, empower data science. And so when I read this vision statement, this is the picture that I form in my mind. We have this incredible asset data source called the PDC that we can learn from, and whatever we learn from that, we would like to use it, apply it in real settings. And so learning can take on many forms, and we usually think developing models, but so we're going to be drawing conclusions from this incredible data set, and we would like to make sure that any conclusions that we draw from that, we want to ask, for me, the question is not so much how will it generalize, but how will it hold up in a particular situation that I want to use it for? And so for me, when I say model development, that model development stage actually involves as much as possible, an accurate estimation of how you think this model or these conclusions are going to help hold up, again, when you use it. And I think this PDC, because of the richness of it, multi-site, it gives us an opportunity to do this properly and fairly. And that's really the bulk of my talk. It's, as we aspire for all these amazing things, some of the ideas that I heard yesterday, let's make sure that we are, and really this is the outline for my talk. And the way that I see this is that I want to make sure that I have a uniform yardstick that everyone uses. Like, I can't have one yardstick for this and a separate one for that. And when I put a tick mark on that yardstick, I want to make sure that I do it as honestly as possible. And so again, that's the outline that I'm going to walk you through. And so I'm going to start with the first two sets. Data partitioning, train and test sets. And I apologize because this seems really, really basic. Cardinal rule: do not train and test on the same data sets. And it really is basic, and yet I have to say I have read one too many papers that somehow managed to break this rule. And I was just reviewing one last week. And so I think there are subtleties that occur about the test set that perhaps, I don't think it's deliberate, it's inadvertent, and so I kind of want to walk you through. And so I want to start with this. What is the test set for? The test set, it is really not for us to try to maximize our AUCs or mean absolute errors that we can publish. It's like, oh, I've got the newest, coolest, best performing anything. I think we really should look at the test set as a way for us to get an unbiased estimate of how when we expect to use this, whatever it is, the model, whatever we've discovered. And so, as I tell our data science team, keep that locked. Use it only once. Once you open it, it's no longer a test set, it goes into development set. So let's make sure that we keep it under lock and key until we are ready to report performance. In fact, a standard practice that we have in our group is that I will make sure you cannot even open a test set until I can read the manuscript of your methodology and some initial results from some other set, not the test set, and you start writing some of the results, and only then and only then do I allow them, okay, now you can look at the test set and everything else. So keep it under lock and key. But you want to be able, since you can only use that once, you want to be able to leverage the other part that's not the test set, because you want some guardrails. If I'm not allowed to look at my test set, maybe there are things that I can put in that remaining development set so that I can, once I open it, I don't have a whole lot of surprises. And so normally we think of it as partitioning the remaining set into a training set and what I'll call a validation set. And I understand, I appreciate that. I think in other groups, maybe how you call the test set versus the validation set, they can get switched. But for the rest of this talk, I'm gonna use this terminology. And normally when we think about the training set, for example, even if I'm training a logistic regression, I'm trying to find the weights in front of those variables. So we think of that as training. Also, people think about hyperparameters. Oh, that's part of the model training. And so they will split this development set into a training set, and again, what I'll call the internal validation set, or maybe I'll optimize my hyperparameters, such as, well, how many variables am I gonna use, and things like that. But I look at this development set as the model development as a lot of stages, not just finding the model weights or choosing the algorithm. Am I going to use a tree, or am I going to use a neural network and the hyperparameters? But even down to how you pre-process the data, am I going to undersample or oversample this thing in my training set? Those are all parts of the model development, and you cannot use the test set to make those decisions. And yes, I reviewed a paper very recently that is using the test set to try to make some of these selections inside the model development set. So again, test set under lock and key. And this, I don't want to get into the weeds between, the regular, what I will call the train val test, partitioning versus cross-validation. But even when you're doing cross-validation, you really need a separate holdout test set, because again, I think this is a common thing that I see when I read or review papers, is that, oh, I'm gonna do my cross-validation, and this is the reported performance, but that's not it. That's still basically, I would look at it as kind of like a possibly optimistic estimate of what it should be on the test set. So there are advantages, disadvantages of this, and if you want to, I'm happy to talk about it more, but I want to keep going in the interest of time. So now we've talked about, well, I'll say the sanctity, the importance of the test set, but how do you decide what goes into the test set? And I think this again goes into the question of generalizability. And so for me, the way that I look at model development and the test set is, well, I'm developing my model, or I'm trying to learn something from this data that I want to use when I try to deploy or use in a real setting. And so when I partition my available data into what I call the development set and the test set, you need to keep in mind this relationship of the available data that you have and how you use it. And so this is what I see. When I partition that test set, I want to try to mimic as much as possible, given the constraints that I have of the available data. I want to mimic that relationship, available data to expected deployment, and therefore my development data set and my test set, as much as possible, try to mimic that, because again, for me, the test set, we should be looking at the test set as a way for us to get an estimate. How do we expect this, the conclusions that I'm drawing from this to be able to hold? Can I quantify that? And that's what the test set is for. And so I'm gonna go through a couple of examples. These are pretty common ways of partitioning when you do the train val test set. So for example, a patient will have multiple admissions. And so if I just say, oh, I can randomly split by admission, but that means that it's possible that I can have admission for little Jimmy in the train set and another admission of little Jimmy in the test set. So that's admission level partitioning. But I can make it a little bit more stringent and say, no, I want to make sure that all admissions of little Billy are in the train, or only in the train set, but nothing in the test set. But there's also what I will call the non-random partitioning, so longitudinal. I want to ensure, because I know that my future deployment scenario, again, that's the future, so I want to try to mimic that, and so that means that I'm making my test set, whatever I put in the test set, whatever I put in my internal validation set, that they are always in the future of whatever I am using to train the test set, and it kind of makes sense. Also, we would love institutional level. Of course, if you only have single institution data, you can't, it's much harder to do this. But so you can try to partition so that you have one or two institutions in your test set that are not at all in your development set. So this is a particular example for a single site data, and our team is actually moving away from that random patient level partitioning to this temporal longitudinal partitioning. And so we've got the test set. We ensure that the test set is always the most recently collected data. Again, no one is allowed to look at it at all. And now here's a particular example of how we're partitioning the development set into a training and validation set. There are actually experiments that we've done on how to do this, and I don't want to get into that, but if you're interested, I'm happy to talk about it during break or some other time. I'm here for the whole day. Again, just making sure. So this, I'm trying to estimate, because of the setup, how I expect my model to perform in a future scenario. And we're actually working on a project, it's not PDC data, where we have multi-site data, and the way that we partition it is that we have a couple of sites that we put in the test set we have not touched at all, and also the most recent years, I think the 2 most recent years from the remaining sites, we have not touched at all, and there are ways that we're partitioning the development set and guardrails, and we're actually, within the development set, what we're doing is, I said, okay, we're gonna have like a little baby chicken test set that we can peek at and look at to kind of assess our models. What are our failure modes? Can we improve? So we are putting those guardrails within the development test set, because I know I don't want anyone to open the test set until the very end. So this is, I think I'll call it my call to arms to the PDC. It's how to set aside a holdout test set, because I would like us to think of that test set as a proxy deployment data set that no one ever touches. But I'm not here to tell you, oh, you need to put this many sites in the test set or these years. I don't know what those answers are, but I would like the group to think about it seriously, what goes in the test set. But I also recognize, that it is evolving. Like within our VPQ data set, when we have a new data pool, the newest data pool goes into the test set, okay, and because we opened the previous test set, now it goes into the development set. But there are many questions here, and I'm actually gonna get back to this in a little bit. Again, many questions to think about how to form that test set. But the other part of the PDC though, and again, as I hear about all these incredible things that one could do with our shiny new ChatGPT or whatever it is making sure that we can track progress, and that's where benchmarks come in. And we want to be able to, again, like I said earlier, track our progress with a uniform yardsticks, and that's benchmarking. And so really this is like my motivation for it. There are like a ton of ICU mortality models out there, and yes, I'm guilty for one of them. But really, it's like, oh, I have this model, but trained on this particular data set, and I'm going to report some metrics. But I have, these other 100 models, but they are trained on different. And I should say, it's not so much the training, it's tested on some data set, right? So whatever metrics that I have here, it comes from a test set, and all the test sets for the same task are all very different. And it's not only the data sets that are different, but the metrics getting reported are also a mishmash of apples and oranges. So when I say which model is best, I'm like, I don't know. Even if I have like a 0.95 and a 0.88, maybe the 0.88 is really bad. I really don't know. And so when I think of a benchmark data set, so certainly you have that common data set that everyone gets to look at and will be tested on. But it has to be beyond that. There needs to be a task where everyone knows the rules and so the evaluation criteria. And this is sort of like a little bit of a refinement in there. And the development set, again, a task, for example, predicting the onset of sepsis or extubation readiness. It could be that. And evaluation criteria, and those are important. I'm not going to get into it right now. But that's available to all. And now the models come out and they get evaluated on that test set only once. So you can think of it as like Kaggle style. And there's actually this recently published paper that describes the importance of these benchmark data sets for healthcare. And the first three are kind of more technical, and we've talked about that. We really want to be able to do that apples to apples, not apples versus oranges or apples versus okra, not that I don't like okra, but we want to be able, again, to track our progress in a fair way. And we would like to enable like comparisons, and we want to be able to reproduce algorithms. But I think really the really important one is the fourth. And this is where this group will come in. That's how I see it. We need to, I would like to see, well, it's not up to me because I'm not a clinician. I don't know what those clinically relevant, meaningful tasks are, target outcomes. And also what goes into these benchmark data sets. And so patient representation, so the selection of cohort. And I'm really glad to hear yesterday someone said, we have to go beyond AUCs. I completely agree. We use AUCs, whatever it is, as a way, as an initial check on, okay, how are we able to extract information? But we need more than that. Meaningful evaluation metrics that make it, I think the word is actionable information for the clinicians using them. And I think this is the hard part, but we need that. And also when forming these data sets, there are many, many questions to consider. When you're building one, do you build a data set for sepsis, a benchmark data set for extubation readiness, or whatever it is, or do you build one data set that can be used for multiple tasks? I don't know. Again, I would like to pose that question to the group. How much data processing or munging beyond the harmonization do we put into those benchmark data sets? And when we're computing the evaluation metrics in a test set, I actually have a picture in the backup where I put a firewall between the masses and the test set, and do I have a grand wizard, maybe Dr. Wetzel as the guardian, in front of that firewall, you shall not pass. Make it a Kaggle style. So Kaggle, for those of you who may not be familiar, actually, how many are familiar with Kaggle? I'm kind of curious. Yes. So in Kaggle, there's a data set, and this is the task, and there's a public leaderboard, but there's a private leaderboard. And no one knows how their models are performing in that private leaderboard. And even the public test set, you give your algorithm to the grand wizards, and they evaluate you on that public data set, and they post your score. But no one gets to see what the scores are. Only the grand wizards get to see how everyone's doing in a private data set. And I saw a talk actually that was really very eye-opening, the differences in the public the data set rankings and the private data set rankings. So anyway, something to consider. And a lot of the questions, the answers to these questions will inform some of the back end, the design of the back end portions of the PDC pipeline that Nelson and Alicia have already talked about. So in summary, I think this is really a stewardship responsibility. We would like to track progress as we dream big with a uniform yardstick, and that is, We do that by designing and building meaningful benchmark data sets. So it's not just, here's the data, go do what you want with it. Like, I think we should be a little bit more deliberate than that. And we want to make sure that we're measuring our performance honestly. And I was talking to someone, like, well, how do I know I'm really 5 or 6, whatever? Did you squish down your hair, or did you measure part of your poofy hair as part of your height? In any case, that's the picture that I have. Do not train and test on the same data, and put the test set away. I'm not going to say throw the key in the Marianas Trench, but do make it secure. And let's try to mimic the relationship of what we, the available data that we have in the expected use case. Try to mimic that relationship when we are forming that test set. And that's really all I have. Thank you. Questions?